right? So expected value, take 2, okay? What does expected value do? It basically is used, this is the main kicker here, it's used to determine whether or not to participate in a game of chance. And it all has to do, maybe I'll do this one more time. Positive EV means gain. A negative EV means loss, right? So basically when you compute this thing and you get your final number, you're going to be looking at the sign, right? And that's what we're going to use to determine whether or not you should be participating in this game. You will find out that it's not always a game. Sometimes if you're bidding for a contract, like every once in a while you're going to get a question where you can make a bid, like you're gonna maybe it will cost you money to actually place your bid and say, I want this government contract, let's say, and it costs you $1,000 to prepare your bid. Like you need to get experts' opinions, you got to get some legal documents. So you're gonna spend quote unquote $1,000 to put your bid in, and then there's a certain chance that you're gonna get the contract. It's still the same thing. It's still talking about whether or not you're going to win or lose in that particular game, right? Quote unquote game scenario. All right, the formula. I need you to understand this, that you're paying attention to this, right? First of all, expected value is a dollar amount final. At the end of the day, it has to have a dollar sign in front of the last value you get. And there may only be one way of winning. So then you would technically only have probability of winning the first prize, and then the price minus the cost, right? You always have to figure that out. This second part here, the probability of winning the second prize, may not apply. There may not be another way of winning. So this would be completely gone, right? If there's a third way to win, then you would continue. Watch what we do. We take this whole thing, and then we add the other probability of winning here, right? And you would continue adding for as many ways as there are to win, okay? But at the very end, you must have this in there, minus, right, probability that you're going to lose times the cost, because you're going to lose that amount you paid to enter the game, to participate. So that's very important. That is the most important part that you cannot forget. So it's going to be add, but at the end you subtract something. There's always a chance that you can lose money, okay? Let's go over to page 70, and I'm going to add a little bit here, okay? This question on page 70 had 2 prizes, 2 ways of winning, okay? And each of them has a certain probability that's going to happen, right? It's based on the context. If you grab a red marble, right, which is 10 out of the 100 marbles in this bag, right, then it's 10 out of 100. To win the second prize, yellow, was 30 out of 100. And I always subtracted the cost from everything, okay? And then at the end, I came up with the 60 marbles that were the losing marbles, right? Here's what I want you to understand. Always think of this. There's always a 100% chance of something happening. Okay, that's your total probability. And basically, you're saying to yourself, right, 10 out of 100 marbles won you the first prize, right? This is prize 1, okay? And then 30 out of 100, that was a little bit more, right? You had 30, this is the second prize. The probability is, so everything that's left here, this is your losing probability, right? Like this is the one you must somehow come up with to get that. So sometimes they flat out tell you, but sometimes you're going to have to figure it out based on the context. Just subtract what you have, right? Because we know this has to be 60 if you're talking percentage, right? 10, 30, and 60. That adds up to 100, okay? So that idea, that thought should always accompany you when you do one of these questions, okay? So let's try another one together. I'm going to do a simple one now. This one is a little actually very, very many moving pieces here. Let's do one that could be done fairly quickly on page 71. Maybe you already did that. Okay. 71. Consider the following game. A 6-sided die or dice is rolled. If you get an even number, you win $3. Okay, this is prize. Prize 1, let's say. If you get an odd number, if an odd number is rolled, you win nothing. Okay? It costs $1 to play. This one I always like to highlight that, right? It costs $1 to play each time you roll. How would you come up? It says figure out the expected value. First of all, let's write out our formula. This would be probability of winning the first prize times the prize, of course, 1 minus the cost. And there's no other way of winning, right? It only mentions one way to win. So we're going to go minus probability that you're going to lose times the cost. Okay? That's what the formula boils down to in this case. And I'll make here only one way to win something. Okay, there's only one way to win something in this case. So let's plug in expected value. Probability of winning. It's a little weird. It's even number, right? So think about, I'm going to go up here. Think about, right? 1, 2, 3, 4, 5, 6. You have, this one is even, this one is even, that one is even, right? So you have 3 out of 6 chances of getting an even number. You win $3, but you remember you paid $1 to play, so technically your gain is 2. Minus, what would be the probability of losing here? If 3 out of 6 is winning, odds would be 3 as well. 3 out of 6 of losing, okay? There are 3 odds. And that you just multiply by $1. There we go, that's it. Clean it up. I will pretend like I don't know that 3 over 6 is half, right? Because it doesn't really matter if you miss that. This is times 2. Just clean the minus up. Times 1, like that. Grab your calculator. Don't rush this one. Keep it separate. 3 divided by 6 times 2. That's 1. Minus. Clear. 3 divided by 6 times 1. That's half. Okay. So 1 minus half is 0.5. Make sure you put your dollar sign and you have 50 there. It's a positive answer. We're expected to gain. Good for you, the player. Bad for the person hosting the game. So don't worry about that. It's positive though, right? Yeah. Which means if you played this 1,000,000 times, you would have quite a bit of money, right? Like on average, 50 cents every time you're gaining. So I would stay on this machine at least. I'd be like, yeah, let's keep playing, right? Will it be true after 5 games? No. Could be that you're losing still after 5 games, but in the long run, you would end up gaining on average 50 cents per game. Let's keep going. Should you play this game? Justify referring to this. Yes, since EV is positive. And don't worry about it being only 50 cents. That is not the point. If it's even 1 cent, but it's positive, you will say it's a good idea to play. The amount doesn't matter, the sign matters. Okay? If you were to play 75 times, how much would you expect it to win or lose? We're winning in this case, so we'll just go 75. I think that's a bit of a small sample size, but hey, we'll go with it. Now what is that, 32.5? 37.5, sorry. It is basically Monday today, so I make mistakes. 37.5. So this question, to be honest, I've never seen that on an exam, but if it were to show up, you know what to do. You just multiply it by your average gain per game, and then you're good to go. Okay. Okay. Given this this question that I just did, so I gave you one that's a little shorter, and the one we did on Friday was a little longer. Right, a little longer. It had two ways of winning, and then we did the subtracting for the loss. I want you to try, before we do anything else, try 72 on your own. I'm going to say this one is longer, okay? You get to win, there's three ways of winning the prize here. Always, there's always a way to lose, but I may not tell you. You have to figure it out based on what you see here. Just remember, there are a total of 2,000 tickets sold. So this is your total. One of those 2,000 wins the first prize. 4 out of the 2,000 win 75 bucks. 20 out of the 2,000 win 25 bucks. All the other tickets, therefore, are losing tickets. They're not winning anything. Okay? So you combined with the total and this, try to write out your expected value formula and try to just use pencil, okay? Don't use a pen, because you might get in trouble. I want you to just try that one. And if you're done that, go to 73 and continue your journey. I'll do at least this one with you and one more before I AC you. Okay, so now you want to ask questions. If you're unable to do this one, you ask questions. I bet you would get partial marks regardless of what your outcome is today. Okay. You should have it in your notes regardless of what you got, okay? So, 2,000 tickets. There are 3 prizes, right? Prize 1, prize 2, prize 3. A warning as well. The cost of playing here is $5, but it could be very high, like the Tri-Hospital Lottery, where you can win like the $1 million mansion and all of those things. That one is, I think, $100 to $200 per ticket. The reason people still buy it has 2 reasons. It's a fundraiser, and it's only in Manitoba, so you're guaranteed that someone is going to win that prize. It's actually a higher chance than playing 649 to win something there. So just be mindful that sometimes the cost of playing is going to be high. Don't let that scare you, okay? So here we go. There are 3 prizes to be won. Therefore, we're going to have 3 chunks that are going to be added, followed by losing, okay? There's going to be a way to lose here, because guess what? If you look at these numbers, it adds up to 25 out of 2,000 tickets. That means that a vast majority is not going to win anything, okay? So here we go. Expected value. I'm just going to plug in 1 over 2,000, right, of winning the $2,500 prize. I paid $5 to play, so I really gain $24.95, right? Plus 4 out of 2,000. $75 is the prize, but remember, you paid $5 to play. Plus another way of winning, 20 over 2,000. Okay, times $25, but you paid $5 to play. There we go. You only gained $20. Minus, you know this is going to be out of 2,000 because it's all just the same lottery, 2,000 tickets sold. I'm going to say 2,000 minus 25 winning tickets. Okay, sorry, it's off the charts there. 25 winning tickets, so there are 1975 losing tickets. Okay, out of this context, I was able to figure this out. Okay, that's 1975 over 2,000. It's the biggest percentage is in here, and you just multiply this by 5. Think about it this way, folks. Why is there a negative here? Because how much what's the price if you don't win anything? 0. 0 minus 5 is negative 5, correct? That's why there's a negative in front of the losing portion of this expected value calculation. And now we just crunch numbers. Okay? So I'm going to just clean that up a bit. This is 24.95 plus. I leave the fractions in this case because it's easier to work with. I'm just cleaning up the brackets where the subtraction is happening. Are you having fun? I hope so. You have a weird definition of fun, Mr. Dirks. Okay. 1 divided by 2,000. Okay. Times 24.95. That's what it is as a decimal, by the way. It's small. Do not round these ones. Okay. Multiply it by the dollar amount. I would write down the whole thing. 1.2475. Plus 4 divided by 2,000 times 70, 0.14, plus 20 divided by 2,000 times 20, that's 0.20, minus 1975 divided by 2,000 times 5, that's 4.9375. Now I'm ready to come up with my final answer. I'm going to put a dollar sign already. So it's 1.2475 plus 0.14 plus 0.2 minus 4.9375. That's negative 3.35. Negative. Make sure the negative stands out, okay? Negative. Okay. So, now we answer. Okay. Should you play this game? Nope. Expected value is negative. Which means that a loss is expected in the long run. If you were to play 98 times, how much would you expect to win or lose? 98 times, you can just multiply this by 3.35. That's 328.30. Okay, to be lost. All right, so that's how you do this one. Yep.
Can you just do negative?
For this one, I think that would be all right to have a negative in front of it because you're losing. I think the province would be okay with that. So either you make sure you say lose, right? Or you put the negative in front of it. I think both will fly. Let's try another one. Because I know you're dying to see another question. Right? Page 74. This one is a little different. That's why I want to cover this one in our journey here. Consider the following game. It costs $3 to play. Okay? You have 1 in 10 chance of winning 25 bucks, 1 in 5 chance of winning $5, 7 in 10 to receive nothing. So what's the expected value in this game? Right? No problem. 1 over 10, and you win 25 bucks, but it costs you $3 to play. There's another way of winning. 1 in 5. You win $5. Is that 5 or does it say 3? I think it says 5. Yeah, it says 5. Right? You win 5, but you played. It costs you $3 to play. And there's a 7 in 10 chance of receiving nothing. Yeah. Go ahead. So they tell you what the losing percentage is here. Okay. So we're gonna go minus 7 over 10 times 3. Here's what I want you to pay attention, okay? You ready for this? What do you think? What do you think this one, and this one should add up to at the end of the day. If I turn them into decimals or percentages, what should all the probabilities add up to? And the answer is 100% or 1. Okay? Always guaranteed. So if you know the first two, you should be able to come up with this on your own. They gave it to you. But let's figure that out. 1 divided by 10 is 0.1 times 22. Why are you turning it into a decimal all of a sudden? Just to show a point here, to make a point. 1 divided by 5 is 0.2 times 2 minus 7 divided by 10. I think you all agree with me, it's 0.7 times 3. Okay, so this one, right, all of these here, okay, add up to 1. Okay, so that's one thing I need you to also be aware of. It should add up to 1. So if you can't figure it out with fractions, turn them into decimals. Turn your probabilities to decimals and then figure out this last one. Because guess what? 0.1 and 0.2 is 0.3, which makes sense that it should be 0.7 of not winning, right? So keep that in mind. Let's crunch these numbers here. 0.1 times 22, that's 2.2, plus 0.2 times 2, 0.4, minus 0.7 times 3, 2.1. Now I'm ready to get my final answer. I think you can prove me wrong. You'll get this one right on the exam. The nice thing is there is not debating like what am I supposed to do here? Is it sine law, cosine law, right? If it's expected value, you go and look up the formula and literally just plug in and be careful as you go. Okay? Is it positive? Yes, right? So that's it. That's it. I'm going to leave it there. But remember, all of these questions that are in between that I didn't do, they're posted on Google Classroom, and you can just look up the answers and see if you can work backwards, all right? All right, I'm going to stop here. So this goes all the way to page 75, I believe. No, I was wrong. 77 if you want more challenging ones. But there it is.